This recording contains 4 time-blocked potentials. The third potential with highest amplitude is used for triggering. Now observe the jitter and blocking in the other potentials. It is very easy to see the jitter in all potentials. Here are 8 sweeps shown in raster mode. The third potential was used for triggering and therefore appears constant on the screen. The first potential has very high jitter, and so does the second potential. The high jitter in the fourth potential is also obvious. Thus we have found 3 abnormal end plates in this recording. But before we jump to this conclusion, we must wonder why there is no blocking in this recording. 3 end plates with very high jitter and no blocking is extremely unlikely. Recall that jitter seen on volitional single fiber EMG is a reflection of 2 end plates, not 1. In this instance, the third potential has the abnormal motor end plate. But since it was used for triggering, it appears constant on the screen. Its jitter is manifested in all other potentials. If we trigger on a different potential, we should get a much different perception of jitter. Let's do so by triggering on the first potential. Here are potentials in raster mode, and we can see the jitter and blocking in the third potential. The 2 other potentials appear to have normal jitter. The tabulated data confirms our visual impression. The jitter between potentials 1 and 2 is normal. Between 1 and 3 is significantly increased with blocking. The jitter between potentials 1 and 4 is 61 microseconds. There is no blocking. Note that the interpotential interval for fiber 1 and 4 is quite high, more than 6000 microseconds. With such long interval, the jitter is exaggerated by the velocity recovery function, which is seen in the plot of the interpotential interval versus the interdischarge interval. The MSD value is much smaller than the MCD value. To reduce the effect of velocity recovery function, we prefer not to accept jitter recordings with mean interpotential intervals longer than 4 milliseconds. Hence, we will reject this from analysis. Here are the 2 values that we will accept for analysis. Note that we have found only 1 abnormal end plate in this recording, not 3 abnormal end plates as we had considered earlier. Therefore, in multispike recordings of volitional method, it is important to trigger on different potentials when significant abnormalities are observed. In stimulation technique, this is not a problem. This is a recording from a patient with a neuropathy. In primary neuromuscular junction diseases, signals with such complexity are quite rare, and the interpretation should be made with caution.